Hi, this is me here from Physics Content. So today's discussion will be about basically when we launch or fire the rocket, we just fire the rocket near the region of perigee. Now the question is here, why basically look at this region in order to fire the rocket? Basically there is some sort of serious physics hiding it. What's that thing? Let's have it. For that, we just go to the what I can call as Earth, right? Now, this is what I can call as the orbit of Moon. Oh, it seems like out of ordinary. So let me just draw here the hypothetical orbit of the Moon. Okay, all right. Now, in addition, if I'm just talking about this is what I can call as Earth, right? Now, we just specifically call this region as, it's known as a perigee region, okay? And this region is known as opposite. Now, the question is basically, when we just launch or fire the rocket, we launch or fire it near the region of perigee. How exactly we can look the problem of this type? Basically, when we talk about the rocket, there is a thrust that's going to be developed in it. And that thrust in the rocket is equal to basically UA dm upon dt. And this UA is basically exhausted speed of the gas particles in a rocket with respect to the motion of rocket. And this is basically the change in the mass of the fuel intake. Okay? Now, let's assume the velocity of the rocket near the perigee is v. Now, when we talk about the power gain, it's basically F dot V. Okay. Now, here I can switch the value of the thrust that has already produced in the rocket. It is going to be U naught dm upon dt, but the symbols have the usual meaning. Now, if dm upon dt is a scalar, I can write U dot V. Okay. Now, here is basically the method of answer. How this dot product can be solved here. I told you, if just for a moment, I will talk about the rocket here. Okay. Now, this is basically the gas particles which are going to be exhaust out after the burning of fuel, and rocket moves upwards with the velocity. Now, the exhausted out gas particle speed is basically opposed to the velocity of the rocket. Now, here I can call as this power gain. It can be written here dm upon dt times uv cos of 180. Hope this is clear to you. Why basically I choose here 180? Anyway, now dm upon dt, it should be cos 180 is negative, so it is minus v naught u. Hope this is clear to you. Now, dm upon dt, it is basically the parameter that must be essentially less than 1. Why? Because when rocket moves upwards, it will eject out gases, and as a result, the mass in the rocket and fuel so that burn the rocket in a due course of time, mass of the fuel in a rocket that will decrease in time. That means this ratio must be less than 1. When it is negative, this is negative, it will become positive. So here it is U naught V dm upon dt. Right? Now, this is the expression for the power gain in the rocket. Now, I will come to my own point that I told initially. When we launch it near the perigee. Now, perigee is a region in which something has velocity more, because this region is near to the earth. Okay, I am assuming that the velocity of this thing will be more. It is because of this fact the distance from perigee to the earth is less, so v should be more. Okay. Now, here it is. Basically, V is here more. That means what? We are getting a more power gain. Okay, when we are getting a more power gain during the rocket launch, it is a sort of good news. And this is the reason. Basically, when we fire the rocket, we essentially fire it near the region of perigee. What is the reason? Reason is basically for the more power gain, and that equation I have printed here. Okay, done.